Lesson 3.1.3, Prime Factorization. First, let's review. Writing repeated multiplication and finding answers. Well, the first one is 4 to the third power. How do we write that as repeated multiplication? Remember, that is 4 3 times. So when you want to write that out, you want to write 4 times 4 times 4, which equals 64. 5 to the second power would be 5 2 times. 5 times 5, which equals 25. Now to go the opposite direction and write them as exponents, remember, what's being multiplied is your base number. That's the big number. 3. How many 3's do we have there? 5. That is my exponent. And if I wanted to find the answer, I would go ahead and I would multiply 3 5 times to go ahead and get that answer. 3 to the fifth power equals 243. The next one is 6. 6 is the base number. How many do I have? 3. 6 to the third power equals 216. Now we want to look at prime factorization. Remember, prime numbers, we've heard that word before, has exactly 2 factors. Only one in itself are the factors for a prime number. Numbers 2, 3, and 5 are prime numbers, but 4 is not because we could use 2 times 2 for 4. That 4 would be considered a composite number. That means I can multiply something besides 1 in itself to get to that number. When we do prime factorization, we want to reduce it as far as we can to get to all prime numbers. For instance, if we did 60, we could say, well, 2 times 30 is a factor of 60. 2 is the prime number there. Then again, I can break down 30 into 2 times 15. Now I have 2 times 2 times 15. I can break down 15 further. Now I still have the 2 times 2, but 15 breaks down into 3 times 5. And then write it as an exponent. Well, 2, I have 2 of them, so I could write that 2 to the second power times 3 times 5. And if I put that all on my calculator, I would see that it equals 60. So that is what you consider prime factorization. Be sure that we know this definition, writing a composite number as a product of prime factors. We normally make a factor tree. You can see that in the example with 40, how we break that down, and that's what we're going to practice today. So here is some more factor trees. Here's one way, finding the factor tree going all the way down. And here's another way, same type of idea, finding a factor tree. The bottom line of the tree must consist of all prime numbers. Here's the one way that Mrs. Smith did it. She picked the factor of 60. She keeps factoring till all the prime numbers are circled. Once you have a prime number, circle it. That tells me I don't have to go any further on that branch. Write all the prime numbers, or consider them all the apples. Don't forget any. I have 2, 3, 2, and 5 circled. Then write them out. I have 2 2s, so I could write them as 2 to the second power times a 3 times a 5. If I multiplied those out, I get 60. Let's do some examples. Let's do number 18. Start with 18 at the top of my tree. What can I multiply together to get 18? I can do 2 times 9. Now, 2 is a prime number, so I want to be sure to circle that. Knowing that it's prime, I know I don't have to do anything else with it. 9 can be broken down into 3 times 3. Again, 3 is a prime number, so I will circle them. Now that I have everything circled, 18 equals 2 times 3 times 3. Now, if I needed to write that with exponents, I only have 1 2, so that stays, but I have 2 3's, so that's 3 to the second power. Here's the next one, 32. Again, 32 is the top of my tree. Break it down into what can I multiply together to get 32? Well, I know that 4 times 8 gives me 32. I also know that 4 and 8, neither one's prime because I can multiply more than just one in itself. 4 breaks down into 2 times 2. 2 is a prime number, circle it. 8 breaks down into 2 times 4. Well, 2 is prime, but 4 is not. 4 breaks down further into 2 times 2. Now I have all the prime numbers. So 32 equals 2 times 2 times 2 times 2 times 2. If you'd like to, as you write them out, you could kind of cross them out so you know you don't miss any. Then if I needed to rewrite this, this is 2 is the base number. How many do I have? 5 of them. So 2 to the 5th power equals 32. Now looking at 45. Again, let's write 45 as the number. Break it down. What can I multiply to get 45? 5 times 9 gives me 45. Well, 5 is a prime number. I'm going to circle it. 9 is not. I can break that down into 3 times 3. Again, now I have my prime numbers. I can write them out in expanded form as 3 times 3 times 5. Then I'd have to write it with an exponent. Well, 3, I have 2 of them, times just 1, 5. Remember, if I put that back in my calculator, it has to equal 45. If it doesn't, then I've made a mistake somewhere. Going down to 169. What can I multiply together to get 169? Well, 13 times 13 gives me 169. And that is a prime number. So 169 equals 13 times 13, or as an exponent, 13 squares. You can go ahead and keep trying the rest of these. I'll go ahead and write down the answers, come back and check them to see if you got the same answer that I got. Welcome back. 216, you should have got 2 to the 3rd power times 3 to the 3rd power. And for 243, you should have got 3 to the 5th power. Using a factor tree is one way to show this. How do 2 factor trees show that there's only one prime factorization? Regardless of which way I do it, if you look at 72, the first time you started with 2 times 36. The next one over here was 6 times 12. Regardless of where you start, the answers will remain the same because they have to all get the prime number. Is one a prime or composite number, or neither? One is neither prime nor composite because it doesn't have any other factors but 1. Go ahead, take a look at your notes. Your homework is page 4. It's due on Thursday.